Hello. Hello.
Hello.
Yeah. Yeah. Hi all. My name is Prakash. I'm math tutor for this webinar. Good evening to all. Yeah. So today we are going to discuss about the topic called rational numbers, the properties of rational numbers, and and the representation of line and all. Okay, not the number line and all. Okay. So I'm going to teach you using whiteboard and the presentation which I have prepared. You can just mute your mics, and if you have any questions in between, just unmute and ask me. Okay, you can just stop me and you can ask me whenever you have a questions in between. You can ask me, and also we have the question and answer session at the last, so you can all ask, you can also ask there. It's there also. Okay, so let's start the rational numbers. So let's start the basics first of all. So what is a number, or what is a rational number? So let me share the whiteboard. So this is the whiteboard. Yeah. So what is rational number? Rational number is a number where we used to write the number as a fraction. So which means if a number is written in a fraction, then that is a rational number. So I will repeat it again. If a number is able to, or if we can write any number in the form of p by q, which is nothing but a fraction manner. If we are able to write a number in a fraction like this, then that number is called as rational numbers. All those numbers are rational numbers. If we are able to write it as a fraction, that is rational numbers. Yeah. And you can see that. What is rational number? A number is a rational if we write it as a fraction. So which is nothing but write it using p by q form, where p is the numerator and q is the denominator. If we are able to write it as a fraction, then it is not a rational number. It is irrational number. Okay, so what are all the rational numbers? Okay, so let's go with the basics of rational numbers. So what are all rational numbers? So the rational numbers can be whole numbers, right? Like for 1, 2, 3, 4 and all. And rational numbers can be integers, which can be a negative numbers as well. And it can be fractions, and it can be decimals, and also percentages as well. So all these are the types of rational numbers, you can call it as, or else all these types are rational numbers, such as natural numbers, whole numbers, integers, fractions, decimals, percentages. The reason why all these 5-6 types are rational numbers, because all these numbers can be written in the form of p by q, which is a fraction form. We can write all these numbers as a fractions. Okay, and let's quickly discuss about each one of these types, which is natural numbers. Hope everyone knows that the natural numbers are the numbers starts with or starts from 1 and it goes up to positive infinity. And the whole numbers is nothing but it starts from 0, right? So it is 0 to infinity. So natural numbers are starts from 1 and whole number starts from 0. But these natural numbers and whole numbers are rational numbers. So what else the rational numbers? Integers, as you see. What are the integers? Positive numbers, negative numbers, and 0. So you can see the definition. Integers are like whole numbers, but they also include negative numbers. So negative integers, positive integers, along with 0. And what else? I mean, what else? What are the other numbers or rational numbers? Fractions, decimals, and percentages. Let me share the whiteboard and let me explain a bit more in this. Just a moment. So as I said again, you can ask me if you have any questions in between. I mean, if you didn't understand anything, please stop me and ask. Okay. So this is the rational numbers representation. It has to be written in a fraction. So what are all the things we learned? Let me write it in a way that. Let's write it in a chart manner. So these are the rational numbers. So what are the types of rational numbers? Hope everyone knows this.
Natural and whole.
Yeah, the natural numbers, and it can be whole, very good. And it can be integers. Integers. And what else? I think these are the basic types we learned. And what are the other three? It can be fractions. The rational numbers can be fractions. Okay. The rational numbers can also be decimals. Decimal numbers. Okay. I've got one question. Let me check what is that. Can the numerator in a, okay, so that's a very nice question. Yeah, I'm about to explain though. What is the fraction says? The fraction says the basic definition of fraction says the fraction there won't be any decimal number in a fraction, so it won't work. For example, 1 by 2 is a fraction, so we are not supposed to write 1.5 by 2. This is not a valid number. This is not in a maths. Okay, so this is not a valid number. We are not supposed to write a decimal number in a fraction. So if you write that, it can't be a fraction, it can't be a decimal, I mean, it can't be a decimal number. So we are not supposed to write. So it can't be a rational number. So the finally, integers, fractions, decimals, finally we can also call it as a percentages. Okay, I will explain why percentages is added in this. Okay. Hope everyone, I mean, able to hear me.
Yes, sir, we can hear you.
Yeah, great. So I think everyone knows that what are natural numbers? It starts from 1 and it goes up to positive infinity. And what are the whole numbers? It starts with from 0. It goes up to positive infinity. Integers starts from minus infinity and it goes up to positive infinity, which means it includes all the negative numbers, positive numbers, including 0. So what are the fractions? I think we know the types of fractions, right? The proper fraction, the improper fraction, and the mixed fraction. Hope everyone knows the types of fraction. So all these three types of fractions are also rational numbers. It can be any type of fractions. All the types of fractions are rational numbers. Nice. Okay, so what about decimals? So it's just a decimal numbers. We do have a decimal point in it. It's like 2.4 or a 5.92. It can be any digits, n number of digits after the decimal or before the decimal. It doesn't matter. For example, for 492.265. So all these types of decimal numbers are also rational numbers. And also in decimal numbers, I hope everyone knows we do have two types of decimal numbers. One is recurring decimals, non-recurring decimals. For example, so it goes on. So this stops. So this is the exact value. This is the not recurring decimals, non-recurring decimals. Okay, so both are rational numbers. Okay, and you might have a question. So the basic rational number rule says we need to write it as a fraction, p by q form, and check whether we are able to write the natural numbers as the p by q form. Yes, right. For example, if you take 5, we can write 5 as 5 by 1. If we take 9 as a whole number, we can write 9 as a 9 by 1. That's why it's a rational number. Integers, you can take a negative integer. For example, minus 8. Minus 8 can be written as minus 8 by 1. So it is a fraction. So fractions is obviously already fraction. So it is a rational number. So decimal number. So decimal numbers are also fractions. I mean, decimal numbers are also rational numbers. Why? Because see, 1.2 can be written as 3 by 2, right? And this 1.333 goes can be written as 1 by 3, right? So that's why all these numbers are, all these decimal numbers are also rational numbers. You might have a question, how about the first three examples? So this number 92 won't end, it might continues. For example, how can you change this into a fraction? 5.92. 5.92 multiplies by 100. So because we have a two decimals, right? So let me write that again. 5.92 into 100 divided by 100. So that 100 cancels out. So which means 592 over 100. So it's a fraction. I think you can see that. So that's why even decimal numbers are rational numbers. Finally, why percentages? How come percentages are rational numbers? What do you mean by a percentage? So we used to represent percentage in a symbol like this, right? Percent, per cent. What do you mean by cent? Cent is nothing but 100, right? Percent. Percent means 1 by 100. So percentage. So 5 percentages can be written as 5 over 100. So that's why even percentages are rational numbers. So these are the 6 different ways of writing the numbers, writing the rational numbers. Hope everyone understand this. Okay, so we'll just wait for 15 seconds. Let me know if you have any questions. If not, we'll go to the next topic. Okay, so I got
just one question, sir.
Mm-hmm.
In percentages, it's 5 by 100, so it's a positive rational number, right?
Yeah, the rational numbers are the numbers can be negative or positive. So in that we can distribute as a positive or a negative. Yes, we can call it as a positive rational number, but it is a rational number. See, in integers, as integers, we have a negative integers and positive integers, right? Similarly, in rational numbers, we can call negative rational numbers and positive rational numbers, but that doesn't matter. So that is a rational number. Okay. Yes, we can call it as a negative rational number or a positive rational numbers, but there is no a particular name as a negative or a positive rational number. Okay.
Okay, sir.
So I got one more question. What it is called when it is 1 by 100? So this is percentage. Percent in a sense, in another way, or maybe in the place value. While you learn the place value or rounding the numbers, you could have learned 1 by 100 as 100th. Let me go to the next board. So I got a question stating that, yeah, no, it's not about 1 by 1000. Yeah, 1 by 1000. So I got a question stating, one moment, what it is called when it is 1 by 100. So 1 by 100 is a percent per cent. So cent is nothing but 100. So percent is 1 by 100. So this is also called as what? TH, hundreds. Maybe when you are rounding, I mean, if you learn the rounding the numbers topic, we use hundredth. And 1 by 1000 you asked. So 1 by 1000 is nothing but thousandth. THS. Okay. So the difference is hundreds, HUN. Let me write that. See, hundreds is nothing but hundreds. This is hundreds. Hundredth, THS means it is 1 by. So for example, TENS, tens means it's tens. Tens is nothing but 1 by 10. Okay. And I hope I answered your question. 1 by 1000 is nothing but thousands, THs. Okay. And when we are all, I mean, when we use this, so for example, in rounding the numbers. So let me write an example, 3427. In this, what is this? This is at 10th place, 1 by 10th place. This is at 100th, th, 100, 1 by 100th place. This is at 1 by 1000's place. So this is 1 by 10,000's place. So, but this one is ones place or a units place, you can call it as. This one is hundreds, or I mean tens place. This one is hundreds, and you can see the difference. Hundreds, tens means we'll get only yes, tens, hundreds. But after the decimal, it divides by 10. So 1 by 10, which is nothing but tenth, hundredth, thousandth, and all. Okay, so this is thousands value. So I hope that clears your doubt, and maybe we're not concentrating on rounding the numbers. If you have any, if you get a time later in the class, we'll try this. Okay. So we're done with the types of rational numbers. And so do we have any other numbers? Do we have any other numbers other than rational numbers? Yes, we have. So those are called as irrational numbers. So if we are not able to write the number using a fraction or in the form of p by q, then those numbers are called as irrational numbers. So what are irrational numbers? Not perfect squares. Not perfect square or square root numbers. So what do you mean by not perfect squares? You might have a question. What do you mean by square root numbers? Square root numbers. Square root of 4. What is square root of 4? What is square root of 9? What is square root of 16? What is square root of 25? So if we take the square root of these numbers, we'll get the whole number. But other than these, so these are all perfect square roots. Perfect square, which means if we take a square root, we'll get the answer as whole number. So other than these, for example, square root 2, square root 3, square root 5, square root 6, 7, 8, 10. So all these are not perfect square root because we won't get whole number.
They are not even numbers.
No.
Not like that. I mean, like many of them are like many of them are odd numbers.
No, it's not about odd and even. So it's about square numbers. Square, it's not perfect square root. I will tell you. I mean, what are the perfect square roots? 1 square, 2 square, 3 square, 4 square, 5 square, 6, 7 square, and then it goes on 64, 81, 100, and what else? 121, 144, 169, what else? 196, 225, 256. Yeah, it goes on. So these numbers are perfect square root, which means if we take a square root of these numbers, we'll get whole number. So other than these numbers, the remaining are not perfect square roots, which means we have a 100. For example, if we take a 99 square root, we won't get whole number. We'll ended up getting a decimal answer. That's why these numbers are called as not perfect square roots. So these are perfect. The below one, which I have written in an orange color. So the blue color ones, these are all not perfect square root. So these are all irrational numbers. Okay. So why I'm explaining the square root numbers here? Because of the irrational. So not perfect. If we take a square root of a number, if the answer is not whole number, then that is irrational number. Those are not perfect square roots. Okay. Do we have any other irrational numbers? Yes, we do have other irrational numbers such as constant values. Constant values. You might have a doubt. What are constant values? The constant values are the value of pi. You might use the pi value, right, while finding the area of the circle. So 3.14 and it goes on. So this value and constant proportionality. Maybe in a ninth class you might learn this. The constant proportionality value or a E value. Yeah, or a speed of the light. So all these are constant values. So those are all irrational numbers. Okay, I got a question. Do we always have to express irrational numbers within a square root? Yes, exactly. So if we don't have a square root, then it becomes a rational numbers. For example, if we take 2 here, if we write just 2, that is the rational number. Square root 2 is a irrational number because we are not supposed to write square root 2 by 1. This is not the correct way of writing, because in square root, in fraction, we are not supposed to write a decimal number or a square root number. Okay, so that's why, yeah, I hope I answered your question. Yes, we need to keep square root sign whenever we are writing irrational numbers. Okay, so let me, before going to the properties of irrational numbers, let me give some numbers here. Please tell me which are the rational and irrational numbers. Okay, let me write 4 square here, and yeah, I have a decimal number. So if you look at this, uh, so you can just tell me on the chart if you want. What are the irrational numbers here? Just tell me the irrational numbers. Okay, so let's go with the pi value. So pi is a irrational number. What else? Does 81 is a irrational number?
Oh, no, sir.
Does 81 is a irrational number? 81 is not a irrational number because square root of 81 is 9. So 9 is a rational number. So it is not a irrational, it is a rational. So pi is a irrational. What else?
So pi is recurring, sir.
Yeah, it is recurring. So the value of pi is 3.14, right? But it is a irrational number. As I said, it is a constant value. So it is a irrational number. So square root of 40 is a irrational number. Square root of 90 is a irrational number. Does square root of 64 is irrational? Square root of 64 becomes 8.
Oh.
So 8 is a rational. So square root 64 is a rational number. What about percentage 5? 5%. 5% is can be written as 5 by 100. So it is a rational number. So the first two numbers are obviously rational numbers. Okay, so we'll discuss the question and answer in the late. We'll discuss these things later. So let's go to the properties of rational numbers. And you can see this, all these type of numbers are rational numbers. Odd, even. So 0 is a irrational number, 0 square root. Okay, so that question. So you're asking 0 is a irrational. No, 0 is a rational number, right? Because 0 is a whole number or an integer. Whole number or an integer, you can call it as. So 0 is an integer or a whole number. So whole number and integers are a part of rational numbers. So obviously 0 is a rational number. It's not irrational. And square root of 0. What is square root of 0? We won't get, right? Obviously it is 0. Square root of 0 is 0. 0 square is 0. And yeah, so obviously 0 and square root 0 is rational numbers. We are not supposed to write 0 square or a square root 0 or a minus 0, right? So all those meanings are same, which is 0. Hope I answered your question. Okay. So now okay, so here you can see that. So all these numbers. So I mean, excluding the other than the 6 types we learned, all these are rational numbers: odd, even, whole numbers, decimals, squares, cube numbers, prime numbers, triangular numbers, composite, negative numbers, positive numbers. All are rational numbers. So all these numbers are rational. What is square numbers? 2 square, 5 square. What is cube numbers? 2 cube, 3 cube, 5 cube, whatever. So what are the prime numbers? Prime numbers are the numbers. You want me to explain the prime numbers? Let me do that. Okay, what are the prime numbers? The prime numbers are the numbers which is divisible by 1 and itself. So the prime, in a sense, for example, if you take a number called 11, 11 is divisible by 1 and 11 is divisible by 11. So except 1 and 11, we can't divide 11, right? If we divide, we'll end up getting the decimal answer. So 11 is a prime number because 11 is divisible by 1 and itself, which is 11. If you take another example of 16, 16 is divisible by 1 and 16 is divisible by 16. Does 16 is a prime number? No. The reason is 16 is also divisible by 2, 4 and 8. So this is not a prime number. So the prime number, in a sense, is the actual number. Yeah. The prime number, in a sense, the number has to be divisible by 1 and itself, the same number. So let's say in another example, 17. 17 is divisible by 1 and 17 is divisible by 17. Other than these two numbers, we can't divide 17 by any number. If we divide, we'll end up getting the decimal answer. Okay. So what are composite numbers? Composite, yeah.
So what are triangular numbers?
Okay. So let me tell you that, yeah. So before that, let me explain the composite numbers and then we'll go to the triangular numbers. So what is composite numbers? Composite numbers, any idea? Composite numbers?
Yeah.
So composite numbers are the numbers which are other than the prime numbers. Which are other than the prime numbers.
Divisible by more than 1.
No. Other than the prime numbers. Let me show you the slide. You'll understand. Just a moment. Yeah, you can see this. In this, you can see the yellow shaded numbers are prime numbers. The yellow shaded numbers are the prime numbers. So you might get a question in exams and all. Write down the prime numbers in between 1 to 10. Write down the prime numbers in between 30 to 40. So you need to write the yellow shaded numbers. The yellow shaded numbers yellow background numbers are the numbers which is divisible by 1 and itself. If you take any example, like let's take a 53 here. 53 is divisible by 1 and 53. We can't divide 53 by any other number. That's why it's a prime. So, and the white shaded numbers, the white background numbers are the composite numbers. Hope you understand the difference between the prime numbers and composite numbers. Prime numbers are the numbers which is divisible by 1 and itself. The composite numbers is nothing but other than the prime numbers. All the remaining numbers are composite numbers. Okay, let's go to the triangular numbers now. What is triangular numbers? What is triangle, first of all? It has a 3 sides. It looks like this, right? Yeah. Oh, yeah. Yes. One is neither prime nor composite. That's good. So the smallest prime number is 2. The smallest prime number is 2. So this is how it looks like, the triangular. So what are the triangular numbers? So it will be in the series of 1, 3, 6, and so on. Let me share one diagram so that you will understand. Just a moment. Just a moment. Yeah, here it is. This one. So these are the triangular numbers. So the triangular numbers are can be written in the form of a triangle. If you see this, so it clearly mentioned it based on the dots, right? So it's clearly explained using dots. You can see that. So it has 3 dots and 6 dots, 10 dots. So in a triangle, how many? So the points, how many points or how many dots can be drawn? So in it has to be it
Are
has
those
to be,
vertices?
sorry,
Sir, are those the vertices?
it's not the vertices. See how it, so it start with 1 and next it start with the 2 in the base I'm talking about, okay, and then it start with 3 and then it goes, starts with 4 and 5, and as you see the difference, the base, the 2, if it
So,
starts with 2, yeah.
yeah, so do the dots need to be evenly spaced?
Dot needs to be,
Evenly spaced out.
yeah, exactly. So one will decrease. So for example, if you start with 6 at the base, so we have a 6 here, and the next one has to be 5, and the next one has to be 4, the next one is 3, the next one is 2, finally 1. So it forms a triangle. Maybe I haven't drawn exactly. So how many points are drawn in this? So that is the triangular number. So if a base is 1, it is 1. So if base is 2, then the triangular number is 3. So these are the triangular numbers: 1, 3, 6, 10, 15, and so on. Okay. So how do we know the number is a triangular number without using the triangular? Okay, that's a good question. So hope you guys learned the factorial. Do you? If you
Yes, sir.
learn, yeah, if you learn the factorial, we just need to add the numbers. For example, 7. So we are not multiplying. Factorial is for multiplication. So I'm just giving a hint there. So if see we learned up to 5. So what is the number if you have if you have a base has a 6 dots? So 6 factorial. I'm not multiplying. I'm adding. So 6 plus 5 plus 4 plus 3 plus 2 plus 1, and check what's the number we get. So that is a triangular number. Similarly, 7 plus 6 plus, and it goes on. Okay, so or else till if you know till 5, so till 5 the number is 15, so 15 plus 6, which is 21. So till 6 it is 21, so 21 plus 7, so that's the number.
So can we find out the original number from the given number? Like suppose the number is coming 21, so can we find out the number 6?
Yeah, the same thing. We can just need to work backwards. That's what. Okay, let me tell you how it works in it. So this. Okay. So triangular numbers you are at. So 1 becomes, and the next part it is 3. So the next one is, you know these two. So you are going 4, right? You are adding 4 to this. See, this is a 1 base. This is a 2 base, 2 dots in a base. So which means you already know these two. You are adding these two plus the next number, which is 3. So 3. So what is the next number? So if you have a 3 dots, so 3 plus 2 plus 1, which is 6. And then 10. So 6 plus 4. So that's how it goes on. Okay, so we'll discuss these triangular numbers maybe a little later if you want to if you want to discuss completely. So let's go to the properties of rational numbers. So what are the properties? We have 4 important properties in rational numbers. What is the first one? It's a closure property.
So closure property, distributive property, and associative property.
And one more?
Associative property and distributive property.
Yeah, you said 3, I think.
Sir, 2, sir.
Okay, that's fine. Let me share that. So the closure property, what closure property says? So the basic types of properties are closure property, the commutative property, associate property, and distributive property. 4 types. Let's start with the closure. So what is closure property? The closure property, so for example, if we take any numbers, any 2 rational numbers, the result has to be rational number. That's what it says. If we take the 2 rational numbers, so if you are doing addition or a subtraction or a multiplication, the result has to be rational number. If the result is not a rational number, then it won't comes under closure property, or closure property won't applies to that. Let's try some example and see. Okay, so let's take any 2 numbers. Let's take 10 and 4. Let's take 10 and 4. So let's do addition. So 10, you know that 10 and 4 are rational numbers. So the result has to be rational number. Obviously, 14 is a rational number. So addition works. Addition works in closure property. What about subtraction? 10 minus 4. It is 6. So 6 is a rational number. So it works. Or else you can also take 4 minus 10 if you want. It is minus 6. Yes, minus 6 is a rational number. So this is also work. So subtraction works in closure property. What about multiplication? 10 times 4, 40. Yes, 40 is a rational number, isn't it? So works. So in any other, in all the cases, not only these two numbers, if we take any of the rational numbers, it has to satisfy all these conditions. Then only it applies the closure property. For example, let's take a 0. Or let's take two numbers as a 8, comma 0. Let's do addition. What is 8 plus 0? So we'll get the whole number. What is subtraction? So 8 minus 0. We'll get the whole number. What about a multiplication? We'll get 0. Yes, 0 is a rational number, isn't it? So obviously it applies, I mean, the closure property works for multiplication as well. So what about division? So in this case, division works 10 by 4, which means it is a fraction. So obviously it is a rational number, but it won't work in this case, 8 by 0. What if we have a 0 in the denominator? It is undefined, right? What is undefined? It's an infinity. So it won't work. So it works in this case, it won't work if we have a 0 as a number. So do we consider does the division includes in closure property? It won't, because it has to satisfy for all the numbers. It won't satisfy for 0, so division won't includes in closure property. So the closure property, we have a closure property of addition, subtraction, and multiplication. In division, it won't work because we have a 0. If we take a 0, it won't work. So that's it of closure property. So what's the second one?
Associative property.
So the second one is, yeah, associative, or else we can go with the commutative property. So what does it mean? What exactly it means? So in commutative property, we have two things. It works for addition or a multiplication. And you can see that it is nothing but it's just reversing a numbers or a swapping a numbers. So changing the position of the numbers. If we change the position of a number, the answer has to be same. Then only it proves, or it is a commutative property. It comes under commutative property. Okay. So what are the things works and what are all won't work? Let's try. So in commutative property, we have addition and multiplication. Okay, so you might have a question, why not subtraction and divisions? Let's try. So let's take the addition. What is addition? A plus B has to be equals to B plus A. So that's what we are doing, right? Swapping the numbers, interchanging the places. In multiplication, A times B equals to B times A. Okay, let's take an example. What's the example? Let's take two numbers, 5, 3. In addition, let's try addition first. 5 plus 3 same as 3 plus 5, isn't it? So that's why, which is both, in both the cases, the answer is 8. So that's why it is an addition. Commutative property of addition. So if we do the multiplication, 5 times 3, it is 15, or sorry, 5 times 3, 3 times 5. So both are same. The answer is 15. So the commutative property, this is commutative property for multiplication. So you might have a question about the subtraction and multiplication, division, right? In subtraction, let's try. 5 minus 3 is not equals to 3 minus 5. Am I correct? Is it equal? It's not. The reason 5 minus 3 is 2, 3 minus 5 is minus 2. So those are not equal. So this won't work in commutative property. So This property is only for addition and subtraction. And division, 5 by 3 is not same as 3 by 5. Okay, so this property says if we interchange the values also, it has to be, I mean, we'll get the result as same. It works for addition and multiplication. A plus B is B plus A, or else A times B is B times A. That's all of the commutative property. Okay, let's go to the next one. Just a moment. So the next one is associative property. What is associative property? So in associative property, we'll ended up getting three digits. Okay, so which means again it works in addition and subtraction, but how? With three numbers or three variables, you can call it as. Let me write it in a capital letters. A plus B plus C, which is equals to A plus B plus C. So I'm just changing the position of the brackets, parenthesis. So this is the associative property for addition. Which means if we change the position of the brackets, the answer has to be same. So it works for multiplication as well. Okay, let's try the multiplication. A times B times C. I'm just using the multiplication dot here. So that's not a decimal point though. So let's say this one. So this is a associative property for multiplication. Let's try some questions. Example. So let's take the numbers as 2 plus 5 plus 7. What will happen here? Which has to be same if we add 5 plus 7 first. I think you know why. I mean, whenever we are solving these questions, these bigger questions, we have to use Bode-Maas rule, right? Which means we are going to solve the parenthesis first, the brackets first. I mean, in this case. Okay, so what will happen here? 5 plus 2 is 7, 7 plus 7, and in this case also 5 plus 7 is 12. So we'll ended up getting the answer as 14 in both the equations, both the signs. So that's why it is associative property. So associative property of addition and multiplication. If you take the same numbers, it works in multiplication as well. 2 times 5 times 7 equals to 2 times 5 times 7. 2 times 5 is 10, 10 times 7, 2 times 35. 5 sevens are 35. So we'll ended up getting the same answer, which is 70. Okay, but if we take the subtraction or a division, it won't work. You want to try? Okay, let's try. Let's try the subtraction with the same numbers. 2 plus 5 minus 7 equals to 2 plus 7 minus 5. Oh, 5 minus 7 rather. 5 minus 7. So 2 plus 5 is 7. 7 minus 7 is 0. But in this case, check what we'll get. We'll get minus 2. Yeah, in this case works because I changed the only position. I changed the only position of this. What if we change it both? So 2 minus 5 minus 7. 2 minus 7 minus 7. Okay, let's try this. What is this? -2, or the -3, -7, 2. What is this? -2, right? And you can see that we'll get -10 here. We'll get +4 here rather. You can see that in some occasions it might work in subtraction, and it won't work for all the cases. So we don't have a associative property for subtraction. So associative property works for addition and multiplication. Okay. So the last one is the distributive property. So this one is the very important one, because we are going to use this distributive property algebra mostly, right? Like in numbers we used to follow this very rarely, but in algebra we used to use this distributive property always. I mean, most of the times. So what is distributive property? It's kind of a distributing the number, or else foiling the numbers. For example, A into B plus C. So we are just distributing A here. So A times B plus A times C. This is what the distribution means. So it can be a negative number here as well. For example, A times B minus C. So if we distribute A times B minus A times C. A times C. And it can be 3 digits as well. I'm 3 variables as well. For example, A plus B, I mean 4 variables, I mean to say. Yeah, this one. So A times B plus A times C. So we are just multiplying the numbers which we have inside the brackets by the number which is outside the bracket. So AD. So it might be negative. So it might be both negative and positive at a time. For example, B minus C plus D. In this case, what will happen? A times B. This becomes A times C. AC minus AC and AD. You want to try some questions? Okay, let's try. Okay. So how do you solve 8 times 8 times, okay, let me take 94. How do we solve this? Are we going to multiply? Yeah, we can multiply and we can say the answer. Let's split 94. How can we split 94? Can we write this 94 as 100 minus 6? And which multiplies by 8. And then you can distribute now. You can distribute 8, which means you are going to multiply. So what is 8 times 100? What is 8 times 6? 8 times 100 is 800, and 8 times 6 is 40. Yeah, so we get the answer as 752. So instead of multiplying, we can use the distributive property to solve this question. So any questions? So here we subtracted, we have a 94, that's why we have taken as 100 minus 6. For example, let's take a little bigger number, maybe a 3-digit number. 1008. What do you do? 3 times 1008. So what we can do here, 1000 can be written as 1008 can be written as 1000 plus 8. So 3 times 1000 is 3000 plus 3 8s are 24. So which is 3024 is the answer. So these are the numbers, and in algebra we are going to use the variables such as x, y, z, or n, k, and all. So this is all about the distribution or distributive property. You can see the definition there. So the distributive property says we can foil in a sense. I mean the number which is outside the brackets moved to inside the brackets, which is multiplies, and multiply a number by group of numbers, add together or a subtract. And or else you can also see that do each separately, each one multiplies separately, and then we add them, add or subtract. Okay. So that's it of the types of or properties of rational number. So these are the 4 properties. Closure property works for addition, subtraction, multiplication. It won't work for division. And the next 2, the commutative and the associative properties for addition and subtraction. This distribution works for addition and subtracting, and also the multiplying. We used to multiply and then we are going to add or subtract. Okay, that's it of the whole, the properties. Okay, let's discuss about the reciprocal of a number. What do you mean by reciprocal? What is reciprocal? The reciprocal of a number is it's just an opposite. It's just 1 divided by. So whenever we are finding a reciprocal of a number, we just need to flip the fraction. For example, reciprocal of 8 is 1 by 8. So we are just writing 1 by the original number. So reciprocal of minus 9 is minus 1 by 9. So what I did, this 9 goes to the denominator, 1 divided by. So what if we have a fraction? You might have a question. So reciprocal of 3 by 4 is 4 by 3, just a flip. So numerator goes to the numerator goes to the denominator, and denominator comes to numerator. Yep, that's what. We just need to flip the fraction. So what else? What about a negative fraction? 4 over 9. It becomes a minus 9 over 4. The reciprocal of minus 4 over 9. And what if we have a mixed fraction? You might have a question. So for example, 2, 1 over 3. Are we going to change directly like 3 by 1? We are not supposed to. The reason, it is a mixed fraction. So we are going to convert that into improper, which is 7 by 3. So 7 by 3 flips, which is 3 by 7 is the answer. So reciprocal of 2 1/3 is 3 by 7. So this is what the reciprocal of a number. You can see the definition in that. So every non-zero rational number, a by b. So if we do that, so it's a by b becomes b by a. So that's what. And the next one, these two, the things you need to learn. Okay. So one is additive inverse and multiplication inverse or multiplicative inverse. So what exactly it is? What is additive inverse? When you add the number to get 0. Maybe you haven't understand. Let me share. Let me write it here itself. So additive inverse. For example, what is additive inverse of 9? What is additive inverse of 9? Let me write it completely. Additive inverse of 9. What is additive inverse of 9? Which is minus 9. It's just an opposite sign of the number. So, and also if we add these two numbers together, 9 minus 9 becomes 0. That has to be 0. Hope you understand. So let's try one more example. Additive inverse of minus 11. it's just an opposite sign. Minus 11 becomes a plus line. So this is nothing but additive inverse. Addition in, I mean, addition of inverse number. So minus 11 becomes plus 9. And if you add these two, minus 11 plus 11 becomes 0. And you might have a question about the fractions. So additive inverse of 5 by 2. What is additive inverse of 5 by 2? We are not flipping the fraction here. We are just writing the opposite sign, minus 5 by 2. When we flip the fraction, whenever we are finding the reciprocal, but additive inverse is nothing but just an opposite sign of a number. And similarly, you can see the multiplicative inverse, which is actually a reciprocal. So for example, 4 by 5, the multiplicative inverse of 4 by is just a reciprocal. That's why I explained the multiplicative inverse first, which is 5 by 4. And if you multiply the original number with the reciprocal, the answer always ones. Let's take another example. Minus 5, I said. So this is the original number. What is the reciprocal of this number? Minus 1 by 5, right? So 5 cancel out, and minus 5, we'll get the answer as 1. So whenever we multiply the original number and the reciprocal of that number, the answer has to be 1. So this is nothing but a multiplicative inverse. Hope you guys understand these two, multiplicative inverse and additive inverse. Let's go to the whiteboard.
Understood.
Yeah, great. Yeah, I think we left with the number line. So the number line, I think you could have learned, you could have maybe know what is number line, at least bit of. So the number line is nothing but all the rational numbers. The number line contains all the rational numbers, which means it has the whole numbers in it, natural numbers in it, the decimal numbers, the fractions. Why not? We can also use the percentages. For example, this is 0, this is 1, this is 2, this is 3. So before 0 we'll get negative numbers, right? So that's what. So using the number line, can you please, let's say this is a city 1, city 1, city 2. Find the distance between the city 1 and city 2, or else find the distance between the two highlighted numbers. What is the distance? So we are going to find the difference, and we'll find the distance, right? So for example, 3 is the maximum number and minus 1 is the smallest number. So minus of minus 1. So the distance between minus 1 to 3 is 4. The distance between minus 1 to 3 is 4. See, 1, 2, 3, 4. You can see that. So the distance between minus 1 to 3 is 4. That's what, even we calculate using math, we'll get the same answer. So this is a number line. Okay. So you just heard that the number line contains all the rational numbers. Does it? We can see only integers. We can see rational numbers. We can see whole numbers. We can see the integers with negative integers. We can also see a whole number which is 0. What about the fractions? Do we have any fractions in a number line? Yes, we do have, right? For example, what is this? In between 0 to 1, it is 1 by 2, right? And for example, if you take another instance, what is this? This is 1 by 4, right? This is 3 by 4, right? So this is the fraction. So in between each number, we do have a fractions. In between each whole number I'm talking about, in between each whole numbers, we have a fractions. We have a many fractions: 1 by 2, 1 by 4, 1 by 8, 1 by 6. So n number of fractions we have. So this is a fraction. So what about a decimal? Do we have a decimal numbers in a number line? Yes, we have. What about this one? This can also be written as 0.5, right? I mean minus 0.5, obviously, from the left side. So what about this one? So let's try in this here. This is 0.75. This is 0.5. This is 0.25. So what is the value of this in a decimal point? Write the value of the mentioned place in the number line. What is the value here? Using decimal, minus 1.75. This is a minus 1. This is minus 2. Before that, we have 0.75. So it is minus 1.75. For example, what is the value of this place? What is the value of this place? Write the answer in fraction. How do you write? 1 and half. 1 and half. You are going to write 1 and half, or else it can also be written as 3 by 2 as an improper fraction. So this is how we represent the rational numbers, all type of rational numbers in the number line. And you might have a question about various percentage. You explain me the decimals, the fractions. What about a percentage? Yes, we can use a percentage. Maybe in the coming classes, coming years, once you're going to the higher classes, you're going to learn the linear equations, the exponential equations, where we use the percentages. Okay, here let me show you what is percentage. 1 by 2. What is 1 by 2? Can we write 1 by 2 as a 50%? So this minus 1 by 2 as a minus 50%. We can write 50% is nothing but 50 by 100, which is 1 by 2. Can we write this as a 75% or else 175%? The value I'm talking about. 3 by 4 is nothing but 75%. So it is 3 by 4, so 175%. So we do have we can use percentages in the number line as well. So the percentages are also the rational number. That's what I was trying to explain. Okay, so that's it of the class. So we learned the types, the basics of rational number, and the properties, and bit of reciprocals and the number line.
Yes.
So please let me know if you have any questions, anyone. You can just unmute your mic and you can ask me the questions, or else you can also ask me in the chat. Anyone? Any questions about anything? So the things which we learned, the basics of rational number, or the types of, or the properties of rational numbers, or else this number line or a reciprocals and everything. Please let me know if you have any questions. Waiting for the questions. Anyone? Okay, which means hope everyone understand completely then. Okay, in that case, if you don't have any questions, let's try some questions and see if you really understand. So can anyone please answer these questions? Anyone is fine. You can just unmute and say the answer, or else you can just type the answer in the chat box. The first question.
So first one is 13, sir.
So I would like to know the reason.
So both of the calculations are same. So like if we take 7 plus 4, both of them has the same answer. And the
Okay.
same way 4 plus 2 has the same answer.
Very good, very
So-
good. And can you tell me which property we used here?
So 1 second, sir. Let me just think 1 second.
Think, yeah. So which property we used here? Anyone is fine. Anyone is fine. Please answer this question. So 13 is the correct answer, yes. But what about the property? Which property we used here? You want me to share the whiteboard again?
Sir, I think it's associative, sir.
Excellent. So we are not supposed to say it's just an associate. We need to say associative property for addition. Okay? In associative property, we have two things, right? For one is for addition, one is for multiplication. So this is not for multiplication. So we have to say associative property for addition. That's nice. What about the next one? What is a missing number in that? Anyone is fine.
Sir, 7, sir.
You said 7. Okay, let's try. So what is 7 plus 5? 12. 12 plus 4, which is 16. Is that correct? Yeah, it is correct. And can you tell me the property here? Which property we used? Which property this indicates? Anyone is fine. Which property it indicates? Whatever you said, the value 7 is correct.
It's just like the previous question, sir. It's associative.
Yeah, associative
Property for addition.
Very good. Please mention that, okay? And even in exams, please write the complete one. So associative property for addition. That's nice. So let's go to the next page. Okay. So what about this one? So first question, what is the missing number in it? Anyone is fine. You can just unmute and say the answer. Or else you can just type. You said 8. Excellent. The answer is correct. And would like to know the which property used here. What is the property name?
Associate property, sir.
Property for?
Multiplication. Associate.
Yeah, you're right. Please tell me the complete name. You're right. Associative property for multiplication.
Multiplication.
Yeah, so that's what you need to tell the complete thing. So because associative property contains two things, one is for addition, one is for multiplication. We need to mention, okay? If we are not mentioning, I don't think we'll get full marks. That's why. So that's nice. What about the next one? Okay. I think what is the value? I mean, so they're not asking the value. They're asking the equivalent correct answer. Anyone? 5 times 2 times 9 is equal to what?
Sir, it's C, sir.
Option C. Excellent. Option C is correct. May I know why? And which property is used here?
Associative property for multiplication.
Excellent. See, just the brackets or the parenthesis changed for 5 and 2 instead of 2 and 9. Am I correct? That's nice. I think I have a few more questions. Yeah, I do have. So what about this one? What about this one? Which one of the following illustrates the associative law for addition, of addition? Which one? Which of the following is
B,
Yep.
sir.
B. Someone said B. Okay, let's check if it is correct. Everyone agrees? Yes, it is B. The reason, see, all looks addition, but the values differs. Here, the values, we don't have a values. So that's not correct. So B is the correct answer. Very nice. So the next one, associative property of multiplication. Which of the following is the correct answer? Who is answering? Anyone can try.
It's C, sir.
You said C. Let me check. Yeah, exactly. See, the reason is instead of 3 and 6, we place the brackets for 4 and 3. But if you look at the other numbers, there is not in a sequence, right? They're not the same numbers are used. Am I correct? Okay. So I think I have only a few more questions left. You can just try the next board. Okay, what about this one? Oh, this is a simple question. Hope anyone can answer.
It's D, sir.
D16 and the property name.
So just 1 second, sir.
Mm-hmm.
Associative law. Associative law.
Yeah, associative law for what?
Addition.
Yeah, addition is good. The next question. What is the missing number in it?
6, sir.
Yeah, that's very good. And it is same thing, associative law for addition.
Addition.
Yeah. Okay, so seems like I have given only associative questions. Okay. Let's go to these things. Yeah, the final set of questions. What is the reciprocal of 12?
12 by 1.
Isn't it? Reciprocal is nothing but a flip the fraction, or else writing the answer as 1 divided by the original number. You got it? Can you answer now?
Yes, sir.
Can you answer now?
1 second, sir.
Uh-huh.
So this is yes, sir. Saw that. Multiplicative inverse.
Oh, I'm sharing the different one. Just a moment. Yeah, this one. So what is the answer? Reciprocal of minus 12. 12. Anyone? What is the reciprocal of 12?
1 by 12.
Exactly. So 1 divided by the original number. So original number is 12. So 1 by 12. As simple as that. So if we have a number, we are going to write it at 1 by the given number. So yeah. Can you tell me the reciprocal of 9 minus 9? What is the reciprocal of minus 9?
1 by minus 9.
Yeah, 1 by minus 9, which is nothing but minus 1 by 9. Generally, we used to write negative negative sign in the numerator, isn't it?
Numerator.
Yeah, so that's why. So what about the second question, 5 by 16?
16 by 5, sir.
Yeah, just flip the fraction. Okay, what about the next one?
4
That's
by
4 by
3.
Yeah, good, very good. So I think I answered the next question, but is there any other, is there any easier way to write, or is there any other way to write? Fourth question. I have answered the fourth question. Minus 8 becomes 1 by minus 8. But is there any other way to write? Yes, right? 1 minus 1 by 8. Hope you got that. So please try the fifth question. What is the additive inverse of minus 5?
5. Positive
Yeah.
5.
Excellent. So which means what? We just need to change the sign of the number, isn't it? So the last question.
Yes, sir.
What is the multiplicative inverse of minus 2 by 3? The last question. Who is answering?
Sir, is it minus 3 by 2?
Yeah, exactly, right? And what is the multiplicative inverse rule says? You like to say? If we multiply the original number and the reciprocal of its number, the answer has to be 1. You can see
1.
that 6 divided by 6 will end up 1. But in additive inverse, if you add those numbers, for example, minus 5 plus 5 becomes a 0. So the answer has to be 0 in additive inverse. In multiplicative inverse, if you multiply the original number and the reciprocal of that number, the answer would be 1. So that's all of these numbers. Hope that clears. Hope everyone understand these rational numbers and properties of rational numbers. Yeah, I'm waiting for the questions. If not, we'll end the class. Anybody? Any questions?
No, I don't have any questions, sir.
Okay. So, I mean, this is the easiest platform to ask questions. In schools and all, it might be difficult to ask questions. You can ask the questions freely. I'm ready to answer. I'm happy to answer. No one is going to see you anyway. So if you have any questions, please feel free to ask. Okay. So I'm considering that no more questions. So yeah, that's it from today's class. Hopefully see you in the next class. Take care all. Take care. Bye.
Yes, sir. Thank you, sir.
Thank you so much. Take care all. Bye.